So we're back to our asynchronous class, organic chemistry. So LP4 concepts. So again, in terms of learning outcomes, I'll only be touching or focusing. We'll just only be focusing on um, nomenclature for LP3, and then for LP4, that is reaction mechanisms. So there are a lot of reaction mechanism. Uh, I only wanted you to know how to use the cheat sheet because we don't need to memorize all those things. Okay, so I'll be forwarding the cheat sheet or the guide for LP3 for nomenclature and for um, of course for reaction mechanism, but on the concept. So I will just be making videos. Again, this is your reading. This should be a reading. You should read these things. But in order for you to say that we have discussed this, so I am making videos. Okay? But you are really free to ask during our discussions about these things. But sadly, nobody asked. So I guess all of you are reading. Anyway, so for chapter 4, I'm just after first, we're just after for these terms. Of course, for us to understand these things, because I'll just be getting the 60% quizzes and exams with respect to the concepts. So, of course, if you can do the learning outcomes, it is already required that you know the concepts before, because you cannot really apply, or maybe you can apply some, but you cannot totally gain the whole skill in doing your learning outcomes when you are not really reading concepts. Okay, but feel free. So you have there are no a lot of terms actually, but chapter 4 actually focuses on cycloalkanes. I guess I as I said, these are the alkanes that are closed group. The alkynes that are not closed group, they are referred to as an open chain organic compounds. While for closed groups, usually you have cycloalkynes, and of course other functional groups might attach to it. And of course, the most common is actually your benzene ring or your arene compounds. So, but anyway, this chapter focuses on cycloalkanes. Okay, so as you can see, these are your cycloalkanes. You have your cyclopropane. So again, that is three carbons, 1, 2, 3. As you can see from the structural, from the skeletal formula, you have three carbons there, you have four carbons there, you have five, and you have six. So it's still the same. You still have the name prop for three. Again, we start with met for one carbon, et for two carbon. For three carbon, you usually use the word prop. And then since it's an alkane, so it should be an cyclopropane for prop. For 4, cyclobutane. Since again says cyclo, butane for an open chain, cyclo if it is closed, pentane if it is closed, if it's open, and then cyclopentane if it is closed, and so on and so forth. While if it has a double bond, you can expect that that would be for this one. If you have one double bond here, expect that it would be called cyclopropene. You have that E instead of A because that is the alkene group, the double bond. So here, if you have double bond, one double bond, it would be a cyclobutene, and so on and so forth. Of course, if you have two double bonds, for example, here, I think you can accommodate two double bonds, though it is not common. So you can call it cyclopropane di, cycloprop, cyclodipropane. Okay? Cyclodipropene, sorry, for the two double bonds. Propene. Cyclodipropene. Okay? For I think it's already stable if you put three double bonds here. How about this one? If you have two double bonds here, that would be as cyclodipentene. If you have three double bonds, that would be a cyclotrypentene. Okay? So the same applies to your nomenclature actually. Then you have your, I think we've already just discussed that, the nomenclature side. So we would basically go to the concepts. So this is the nomenclature. Then you have the cis-trans isomerism. So as we dig deeper, as I've told you, there are a lot of isomerisms in organic chemistry. For double bonds, actually, one of the known are the cis-trans. Cis-trans isomerism, meaning you could have different compounds with just the arrangement from the double bonds. Okay? So if you have a double bond, you only have two attachment to every carbon on that double bond. So if those attachment will appear on the same side, we call that a cis, same side. So we can also draw it in a similar function that the the those particular groups, referred groups, because you have to say cis and then that two particular groups. So if that is a methyl and an ethyl, so you would probably say cis ethyl methyl, okay? Or probably the numbering. If that carbon double bond is number 1 and number 2, so you might be, or number 3 and number 4, you might say cis 3 4 cis 3 4 ethyl methyl, or oh yes, because you would start with ethyl. You cis 3 4 ethyl methyl and then the parent chain. So this is a cis trans. That is, you have a double bond. Okay. Cis-trans isomerism can also occur by just, I think we've already discussed this with chapter 3, the conformations. So you can also have the cis conformer if you have both, like this one, this hydrogen and this hydrogen are close to each other, and like if this rotates, this hydrogen would be far from this hydrogen. So if you're just referring to the hydrogen, we would call it cis. And also for cyclo compounds, you can also use the cis trans. Actually, I think here you'd be sorry. So cis trans is already introduced because it will be discussed in double bonds. Actually, it is more common in double bonds, the cis trans isomerism, and also for cyclo compounds. If you will draw a particular group in the upper and another particular group in the lower, you might say, or you should say, that those two groups is a cis, or a trans actually, if both of them appears in different sites. So usually if you use cyclo compounds, we usually draw them in a in a horizontal manner, meaning we are looking at them at this side on the horizon, wherein the three double bonds is as if in line with our eyes, or probably tilted somewhat so that we can see them three-dimensionally. And then we refer cis if those groups appear on both sides, meaning on the upper part, because with the horizontal, you only have two groups, the upper group and the lower group. So if those groups are at the top, so we will call them cis, and if the other one is at the top and the other one is at the bottom, then we call them trans. See, this is a methyl, so we say trans, and then dimethyl, so both are methyl. So again, if those are not methyl, you're just referring to a particular group. Let's say this is chlorine and methyl, so you will say transchloromethyl. Okay? So, and this one is a cis. So that's where the cis comes from. So actually, it is already under the stereoisomerisms. So it's one of the isomerisms. As I've told you, I guess we've already introduced the positional isomers and the functional isomers. This one is stereoisomers. So they only differ three-dimensionally, because if we will not view them in a three-dimension fashion, just like putting in a horizontal, the other one is at the top and the other one is down. But actually, that the horizontal somewhat tilted, so you can see the three dimension of that. So we call that stereoisomers. Stereoisomers, because stereo means the 3D, mean the space. Meaning, if because if we're just talking about a 2D, basically you're just talking about a flat surface. So stereoisomers is referring to they become isomers on the 3D side. especially with like this one, the cyclo compounds, the double bonds. You have cis and trans for that. So you have constitutional isomers again. You have different placement just with the same elements. Isomers again, as iso is same, mers is units. So they have the same carbon and hydrogen. So we call them isomers. But for this one, this is constitutional isomers, meaning the rearrangement is are different. While stereoisomers usually the arrangement on the 3D, just like this, on the upper and the lower, so it is being highlighted. So that is in stereoisomers. We have a lot of those for double bonds, for um, even for biomolecules, which is an important subject to you. Okay, so you have to know these things. And then we have LOs. I will not be, of course, some, the easier ones, we will discuss, and I will be, as I do the learning outcomes for you to follow, of course, these simple ones, simple ones, of course, we will tackle that one even during LOs. Example, putting cis trans with respect to your nomenclature, that would be not that hard. Okay, but if the learning outcomes talks about already energies and other stuffs, for example, it's usually on the energy part because we discover or analyze substances with respect to interaction, and we can only interact with in terms of energies. So we will not deal on those things. So this trans is still okay. So as you can see, your chlorine and CH3SA is a trans, because as you can see here, the line dash wedge is being used. Why? So that the three dimension would be highlighted, meaning uh, would be emphasized. This one, the methyl and the ethyl is on the same side, meaning from the wedge it is on the front side, it is protruding to the front side, that is the wedge. The broken lines are assumed that they are at the back. So again, for the same side, if they are both at the back, they are also cis. So this one is a cis because they are both at the front. So we could call this a cis methyl, and this is ethyl. So we will first look at the ethyl, but the number one, of course, would be on this side. So that would be a cis 1 3. Cis 1 2 3. So that this should be a cis 1 3 ethyl methyl. Or probably you can say cis 1 ethyl 3 methyl. You can separate them. Yes. Cis 1 ethyl 3 methyl, and then you put the cycloheptane for the name of that one. And then you have, of course, drawing the reverse of that. So, and then we go to, so in terms of LO, we'll be doing that because this is an LO, of course, the simpler ones. The next is stability of cycloalkanes. But I guess I have to pause because the video is already